So very good day to everybody. This is Computer Communication Networks, and in this class we discuss about the multicast routing and its basics and about the intra-domain as well as inter-domain protocols. Okay. So I already discussed about unicast routing protocols in the last class. So in this class we are discussing about multicast routing protocols. Okay. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again let me thank God for giving this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. In this class, we discuss about how you try to deliver IP packets using defined routing mechanisms. Then we discuss about distribution trees, how you'll allocate, how you'll reserve the IPv6 multicast addresses. Then we discuss about multicast distribution trees. Then we discuss about RP, rendezvous point, okay, and about the shared tree, reverse path forwarding RPF, DVR distance vector routing, and finally we are going to end this class with intra-domain and then inter-domain routing mechanisms. Okay. So at regular intervals, I will be giving you some short videos to discuss the knowledge in our topics. And once again, I am reminding you that you have to complete the independent work and the open internet project work for computer communication networks. Okay. Fine. So when it is coming to delivering the IP packets, there are three different methods. One is unicast, broadcast, multicast. So unicast means one-to-one, which means that the packet is being sent to single destination. Okay, so from the source you are going to send to the destination. Then broadcast means one to many or maybe one to all. Okay. You'll have broadcast and multicast. That is the only difference. Like broadcast, it is one to all, and multicast, it is one to many. Okay, fine. So here broadcast, here the packet is sent to an entire network, but multicast, it can be sent on different networks. Okay, so many to many communication is also there, which means that the multiple sources are there for the same destination. Okay, where the source is also a destination and you can send it to many destinations. Okay, so maybe in the case of video conferencing, okay, like Skype or maybe Zoom Meet or maybe Google Meet, everywhere like we'll have like many to many communication. Everybody participate. Okay, like for example in the video games also, like maybe like PUBG or maybe Free Fire, whatever maybe, several try to participate, several try to interact, and several go to like different stages. Okay, so that is what you have with the multicast. Okay, right. So the multicast, only the destinations that are indicated maybe will receive this multicast traffic. So based on the messages that is being sent, okay, you receive the multicast traffic. So you can say that the job of the routing devices, maybe you have to explicitly identify between the source and the receiver, and you are going to define the correct logical network topology that you belong to. Okay, so maybe you can use this unicast or maybe multicast points also to correctly route the traffic. Okay, so maybe if you have a video server which is going to act as a multicast source, then maybe if it is going to broadcast maybe a live football or maybe a cricket match or so on, so the stream of the traffic can be sent by the server in the single stream of packet to a particular multicast address. So here the multicast routers will be forwarding this multicast packets to all of the multicast receivers that is being registered on the multicast address. So here the multicast routing devices will be replicating the multicast packets from the incoming interface, and it will be sending the copies on the outgoing interfaces. Okay, so here it will be preventing this routing loops, and that is the function of this multicast routing. Okay. So the case of the basics, the basic criteria is that you have to prevent the flow of unwanted traffic. You have to keep it to the minimum. Okay, so the source that does not want to receive this multicast traffic maybe should receive zero multicast messages or maybe close to zero multicast messages. So here IP multicast will be acting as a center point, and it will be a set of receivers which are interested in receiving a particular set of data traffic. Okay, so here it should be joining IGMP, Internet Group Management Protocol. So for example, like a source, the router 1, okay, so you'll have router 2, source 2, okay, source 3, and in turn it will be going into receiver 3 and receiver 4. Okay, 2 across the different destination D1, D2, D3, D4 up to D10. Okay. And then here you will have distribution tree. So the routing device in the IP multicast networks, here you have to build the distribution tree. So that is going to connect the receivers to the sources, and here the distribution tree has the source as its root. Okay, and here we will be having two types of interfaces. One is upstream interface and then downstream interface. So here the interface which is leading to the source, you can call it as the upstream interface, and the interface which is leading to the receivers, you can call it as the downstream interface. You can also call the upstream interface as the incoming interface. Okay, so which is coming inside. Okay, and the downstream interface you can call it as the downstream interface. Okay, so here both the incoming as well as outgoing, maybe the upstream as well as downstream interfaces are rooted in the command line interface outputs. Okay, so here the multicast will be using class D IP address range, maybe like 224.0.0.0 to maybe 239.255.255.25. So this is the class D range. Okay, so here you will be having unicast IP address, and the destination IP address will be a multicast address. Okay, so the link local address you will have 224.0.0.0, and then globally scoped address it is 224.0.1.0 to maybe 238.255.255.25, and then source specific multicast it is 232.0.0.0, and glob address it is 233, and then limited scope address it is 239.0.0. And then reserved IPv6 multicast address. So here the link local address range is being reserved, okay, for the local network segment, and maybe the router will never forward the packets with the destination IP address. And here the range, the prefix is actually FF008 prefix. Okay, and maybe like IPv4, the IPv6 multicast will be used for some particular purposes. So IPv4 and IPv6 they are similar in operation, and there are reserved IPv6 multicast protocols that has been reserved, like maybe like open shortest path first version 3. Okay, resource initiation protocol as well. Okay, like with the case of protocol independent multicast. And then in the layer 2 we will have MAC addresses, and then there is a single VLAN also, virtual LAN also. Here the source IP address will be the IP address of the source. Okay, and maybe if you take in the case of destination MAC address, here the 25th bit would be set to 0, and maybe for multicast the 25th bit would be set to 1. Okay, and here the range of the MAC address will be ranging from 0 x01 005e0000 up to 0x01 005e up to ff. Okay, so you can convert this multicast IP address to a MAC address also. So these are the multicast distribution trees. So we'll have source, then router across several routers to the host. So here there will be 32 IPv4 multicast addresses, and the destination, the distribution trees are being created in order to control the path that the multicast traffic is going to travel across through the network. So here we will be using the source tree, maybe the root you consider as the source, and here we will be using shortest path tree in order to find the optimal path to reach the destination. And here you'll have the shortest path tree for the group 224.1.1.1. It is being routed across the source 192.168.0.1, and you'll have a receiver 192.168.1.1. so that you will be seeing here. Okay, from 192.168.0.1 it will be routed, okay, across to reach the final receiver, okay, the host 192.168.1.1. okay, so maybe here it will take R1 to R2, R3, R4 and to the receiver. So this is the shortest path. And then you'll for the shortest path tree, the multicast state you can specify as S, G. Okay, so here you'll have the point, the above shortest path tree, like 192.168.0.1 comma 224.1.1.1. so this is actually the source, and this is the gateway, okay, that we have passed. So here it will be having R1 to R5 across the protocol independent multicast register. Okay. So from here the multicast packet will be passing on to, and here it will be encapsulating in the protocol independent multicast register message for the routing protocol and to the protocol independent multicast register to R5. Okay. So here we'll be having a separate shortest path tree for each of the source which is sending the multicast group, and here we will be also having the shared tree. Shared tree means it will be sharing commonly. Okay, so it will be having a common route placed in the network. So this sharing you will be having as a rendezvous point RP. So it's a shared tree for the group 224.1.1.1. Here the root is located in the router R3. Okay. So 192.168.10.1 it is being shared. Okay. And here 192.168.0.1 that is also there. Okay. From here it will be going on to the receiver 192.168.1.1. So the source traffic is being sent to the rendezvous point, okay, across the source tree, and it is being shared, okay, forwarded across the shared tree to all the users. So here it will be having like G entry like 224.1.1. The advantage is that it will be creating an optimal path between the source and the receiver, but disadvantage is that the router must maintain the same state for the each of the source. So that is the main problem. Okay. So this is the case of the shared tree like R1, R2 across the rendezvous point. It is being shared through the R3. Okay. So this is the multicast traffic that is being transferred. Okay. So this is the source tree. Okay. And this is the shared tree that is being carried over. Also, the advantage of the shared tree is that the routers has to keep less multicast state. Okay. But disadvantage is that the state, I mean the path between the source and the receiver is not optimal. Okay. So when the path is not optimal means it will create a latency. So latency problem will be there in the case of the shared tree. And then you will have multicast forwarding. Okay. So as you see in the diagram, the multicast group are there. Okay. So that is being transferred across the network. Okay. So the multicast forwarding, the source, okay, so that will be sending a traffic across the group of hosts, and then you'll have reverse path forwarding also, that is traveling the forwarding the traffic away from the source. Okay. So maybe RPF, reverse path forwarding, is a very important concept in the multicast forwarding. So here it will be using unicast routing table to determine the upstream as well as downstream neighbors. Okay. So here the router will be forwarding the multicast packet only if it comes from the upstream interface or maybe the incoming interface. And then you have reverse path forwarding. So here it will be checking a loop free distribution of the multicast traffic, and the traffic will be forwarded only if the packet passes the reverse path forwarding, that mechanism. Okay. Otherwise packet will be dropped. Okay. So here it will be working like this one. The router will be checking in the routing table to see if the source of the multicast traffic is actually reachable through the same command line interface. So if it is the same means it will be passing the RPF, reverse path forwarding check, and the traffic is being maybe forwarded. If the reverse path forwarding check does not pass means traffic will be dropped. So here we are going to identify the differences between intra-domain and then inter-domain routing protocols. Here the intra-domain, intra means within, inside, inter means across. Okay. Intra means routing algorithms works only within domains, but in the case of inter-domain routing works within and maybe between the domains also. And intra-domain, it needs to know about other routers, okay, in the domain. But in the case of inter-domain, it needs to know about other routers within and between their domain also. And intra-domain, generally the protocols used are interior gateway protocols, and here inter-domain, exterior gateway protocols. And here in the intra-domain, the routing takes place within an autonomous network. But if you take in the case of inter-domain, the routing takes place between the autonomous routing networks. Okay. And in the case of intra-domain, it will be ignoring the internet outside the autonomous system. But in the case of inter-domain, it will be assuming that the internet contains the collection of the interconnected autonomous system. With the case of intra-domain, like we'll use like resources information protocol, or we open shortest path first routing protocol. But in the case of inter-domain, we'll be using border gateway protocol, and maybe that will be used to connect two or more autonomous systems. Okay. Then you'll have resource information protocol, okay, like distance vector routing. So here the node in the domain will be storing information about its neighboring nodes. So the corresponding cost is being associated, that will be stored, and here the information will be stored in the routing table. Okay, so here resource information protocol is the earliest distance vector routing protocol because it will be using the hop count, okay, to calculate the routing statistic. Okay, so here resource information protocol will be avoiding the routing loop, so that is the advantage that you will enjoy with the distance vector routing. And then you will have link state routing. So similarly, a routing table will be maintained. So every node in the domain, okay, will be storing the information about all other nodes, and here the routing table will be storing information about the entire topology of the domain. Okay, so maybe you can use distress algorithm as we discussed in the previous classes to calculate the best optimal path or maybe the routing path. So actually this is made possible by the open shortest path first algorithm, and that is the advantage. So maybe across the link state packets, okay, we'll be having a topological database. So that will be using shortest path first algorithm, okay, so to maintain a tree that will be calculated or will be stored in the routing table. So this is the difference between intra-domain and then inter-domain. So maybe domain 1 you'll have A, B and C that is being carried over within the network, but inter-domain it will be carried out between the networks, like domain 2, domain 3, domain n. The across the domains it will be communicated.